Welcome to David Alexander Maths Tuition. This is chapter 10D on solving trigonometric equations. So find solutions to the equation tan of x equals 7 in the range 0 to 360. So if the tan of x is 7, then x is the inverse tan of 7. So therefore x is, let's call that 81.9 to one decimal place. Now we need to remember that with tan, it repeats every 180 degrees. We've got an asymptote at negative 90, so the next asymptote is 180 degrees later, positive 90, and the next one would be at 270. Anyway, we're not too worried about the asymptotes here. So here we are getting, let's say here is 7. So I'm getting this solution is my 81.9, but if I draw the whole tan up to 360, which is there, so this is 360, there's also another solution 180 degrees later. So our next solution is 81.9 plus 180, so 261.9. If you wanted the next solution after that, just add another 180. If you wanted the solution before the 81.9, subtract 180. So just remember, sine repeats every 180 degrees, really easy. Let's take a look at the next one. If the sine of x is 0.5, then x is the inverse sine of 0.5. So shift sine 0.5, and we are getting x is 30. Okay, so let me show you what to do for sine. So here is a sine curve between 0 and 360. So I'm getting, so this is 0.5 here approximately. So I'm getting that one solution there, and that's 30 degrees. But also there is another one at this point here. Now that is a distance of 30 degrees from the origin, of course, 0 to 30, so that's 30. This distance here is also 30, but it's 30 back from 180. So all we need to do is, for the next sine solution, is do 180, take away what the primary one, what this one your calculator shows is, and this will always work. So whenever you do the inverse sine of something and you get one solution, the next solution is 180 minus the answer. So x is also 180 minus that answer. So x is, I mean, in this case it's fairly obvious, it's going to be 150 degrees. But if you get some really obscure, like really nasty value with lots of decimal places, just do 180 minus it, you get the next one along. Okay, so there are my two solutions. X is 30 and x is 150. Okay, so cos of x is 0.2, so x is the inverse cos of 0.2. So x is, right, grab the calculator, shift cos 0.2, 78. Let's just call it 78. Okay, so let's just draw cos from 0 to 360. Okay, it's not brilliantly drawn. But 0.2, let's just say that 0.2 is there, and my calculator has given me this solution here, which is below 90, 78. But there is another solution here. Now we know that this is 78 degrees, and this distance here, remember this point here is 360, so my next solution is x is 360 minus 78. So x is 360 minus answer, which is 200 and, well, let's call it 282 degrees if we're rounding it to the nearest degree. Okay, so what you need to remember is that for tan, just plus or minus 180 degrees. For sine, once you've got your first one, your next one is 180 minus the first one, and for cos, it's going to be 360 minus that first one. Now with sine and cos, remember, let's previous, for the one that we had for sine a moment ago, we got 30 and 150. So let's say we've got 30, then 150. There might be, well, possibly you need more solutions. What you need to remember is that sine repeats every 360 degrees. So we've got our first pair. They come in pairs. The first one is 30. The next one is 180 minus 30. And then to find the next pair of solutions, we are just adding 360. Remember, sine repeats every 360. So does cos, by the way. So for this one, we've got the two cos values of 78 and 282. But let's say that this range was 720, then we'd need the next two as well. Again, the third one would be 78 plus 360, and then the fourth one would be 282 plus 360. So once you've got a pair for sine and once you've got a pair for cos, get the next pair. We can also get the previous pair by subtracting 360. Tan's different, tan's easy. Just keep adding 180 or subtracting 180, no problem at all. Tan's the easy one. Okay, find solutions to the equation 7 tan x equals 30. So dividing through by 7, the tan of x is 30 over 7. So x is going to be the inverse tan of 30 over 7. So 30 divided by 7, shift tan answer. I'm getting x is 70, just call it 77 degrees. So the next one is going to be 77 plus 180, which is 257. I could work out the next one as well by adding on another 180. I'm getting 437. Sometimes it's good to find too many. If you know you've gone beyond the limit, well, get rid of it. At least you know you haven't accidentally missed one off. So this next one is quite similar. So the cos of x divided through by 2 is negative 0.2. So x is the inverse cos of minus 0.2. So grab the calculator, minus 0.2. Inverse cos answer is 101. So x is 101, or let's call it 102, let's call it 101.5. Now remember the next value is going to be 3 for cos, it's 360 minus this one, and x is 360, well, let me just write that down, 360 minus 101.5, so 360 minus answer, and I'm getting 258. Okay. So there's solution 1, there's solution 2. If I want solution 3, I'd add 360 onto this one here. But 101.5 plus 360 is obviously going to take me beyond 360. So remember when you're finding the second cos solution, subtract it from 360. If it was sine, you'd subtract it from 180. Okay, let's take a look at this one. Find solutions to the equation 3 sine x equals 5 cos x. Okay, so what do we need to do here? Okay, so what we can do here is we are going to be dividing by sine x. Why are we doing this? Well, first of all, we can't cope with an equation that's got a sine of x on one side and a cos of x on the other. But if I divide through by cos of x, first of all, that knocks out the cos of x on the right hand side there. And what is sine of x over cos x? That's right, tan x. So we've got 3 tan x equals 5. So when you've got an equation in terms of sine x and cos x, divide through by cos, it will turn everything into tan. So 3 tan x equals 5, so therefore tan x is 5/3. So x is going to be the inverse tan of 5/3, and that is 59. And we will get another solution. If I add 180 to that, that'll be 239. And if I add another 180, I'll be beyond 360. Okay, so here's another example. What am I going to do here? A little bit different to the previous one, but hopefully you can see that if I subtract 5 cos x from both sides, I'm going to get root 7 sine x is 5 cos x, divide through by cos x. That will knock out the cos x's on the right hand side, and I've now got tan x on the left. So root 7 tan x is 5. So therefore the tan of x is 5 divided by the square root of 7. Okay, so shift tan 5 divided by root 7. I'm getting 62 degrees. And remember for tan, all we're doing is adding 180 every time. So I'm going to add another 180 to get 242. And if I add another 180, I'll be outside the stipulated range. So just two solutions of 62 and 242. Okay, so here's two more examples, but this time the range is a little bit nasty. So 3 tan x is 30, so I'm going to say that the tan of x is 10. So therefore x is the inverse tan of 10. So shift tan 10, I'm getting 84 degrees. Okay, so the next solution, I'm going to add 180 to that. So x is 264 degrees. I'm just rounding to the nearest whole number here. I'm going to add another 180. So x is 444. So remember, tan, you're always just adding 180 every time. It repeats every 180 degrees. And my next is 624. Right, don't need that one. So I've gone far enough in this direction. So let's go back to the 84 and let's start subtracting 180. So before the 84, I'm going to get a solution of negative 96. And if I subtract another 80 from that, I'm getting x is minus 276, but that is lower than minus 180. So there's only 4 solutions: negative 96, 84, 264, and 444. Okay, so again, nothing new to begin with. I'm just going to say that the cos of x is 0.8 over 3. So therefore x is 0.8 divided by 3, and inverse cos that answer, 70. Let's call that 75 to the nearest whole number. Now the next value is going to be 360 take 75. 360 minus answer, so I'm getting 285. Okay, right, so if I wanted to work out the next value, I'd add 360 to 75, but already I'm beyond the range, so I can already get rid of this 285. Now I'm interested in the ones that are before this. Now we need to see these as a pair. So the next pair before, what are they? Well, this one here is going to be this value here minus 360. So 285 take away 360 is minus 75, and this one here is this first value minus 360, and 75 take away 360 is minus 285. And it's quite logical as to why we're getting the same solution, well, why it's just plus or minus 75 and plus or minus 285. Well, that is because cos is symmetrical about the y-axis. So if I'm getting 3 cos x is 0.8, so let's say I'm getting 0.8 here, we can see that this solution will be the same. Well, this is the positive value, this is the plus 75, and this is the minus 75. This distance here is the same as this distance here from the y-axis.